United States Navy, with ships and with aircraft, is making valuable contributions to our knowledge of Antarctica. Air operations have immeasurably accelerated the study of this polar continent. Fixed-wing aircraft are used for rapid visual observation and photographic survey of very large areas. Air reconnaissance is a swift, effective way of finding trails through crevasse areas. Fixed-wing aircraft serve many other purposes, including the transport of personnel and supplies. An example of supply transport is this emergency refueling operation of a C-124 by a P-2V on the ice at Cape Hallett. Helicopters, too, perform many tasks. For example, they are used for deliberate, low-altitude visual reconnaissance. Helicopters range over the sea ice ahead of surface ships to find the best route through the ice. They deliver scientists and their equipment at locations which make other transport impracticable or even impossible. Helicopters are also used for rescue. The variety and scope of Antarctic air operations are indicated by the parachute rescue team, all volunteers for this additional duty. Maintenance and repair, of course, are part of the total air activity. Work is slow and difficult. You must wear gloves because in the intense cold, bare hands can freeze to metal. Snow is another obstacle. But whatever the problem, it is solved with ingenuity and with the equipment at hand. From our Antarctic experience, we have learned much about air operations in ice and snow and in extreme cold. As a contribution to this store of information, this film shows some of the techniques and procedures for ground operations, and also for takeoff and landing. To prepare aircraft for flight, the first job is remove the snow. This plane has been parked all winter, but in a short time, a blizzard can also pile up a lot of snow. In such cases, snow removal is quite a job. In situations less severe, snow often can be removed simply by sweeping. In any case, a general snow cleaning job must be done before starting the ground check. In the ground check, as a first step, All flight control hinge points must be cleared of snow and ice. Use a wooden probe to get it all out. Remove ice and snow from the engine nacelle. Be sure that breather and vent lines are clear. Remove the fuel strainer. In very cold weather, ice crystals may form in the strainer and clog the system. Remove these deposits. Next, inspect the landing gear. You'll find specifications for pressure and strut distance in the wheel well or on the strut itself. Examine snubber cables. They should not be frayed nor worn. Clear the ski channels. Look under the ski. As far as possible, make sure the Teflon bottom covering is undamaged. Check the JATO assembly. Make sure the racks are secure. In the rack area, look for loose rivets or wrinkled skin, the kind of damage that can be caused by JATO thrust. Make sure the electrical leads are undamaged. Heaters like these are usually needed to warm aircraft engines for starting. Portable heater engines are kept in a warm shack so they'll start easily. The ducts which carry heat to the aircraft are also stored in a warm place because if they are extended while cold, they'll crack. An adapter ring permits the use of several heat ducts. Ducts are attached to openings in engine covers called banjos. In addition, heat can be led to other points according to the requirements of different aircraft. Because it may take as long as 3 hours to preheat an engine, planes in ready or standby are heated continuously, and multi-engine planes may require more than one heater. Before starting, remove the banjos. Using the auxiliary power unit, turn the propeller through 6 to 9 blades. Attempt to start as soon as the engine turns over easily. Don't operate a starter continuously for more than 1 minute. Between tries, rest 3 to 5 minutes to cool the starter. Continue starting procedure until the engine reaches normal idling speed. In extreme cold, use carburetor heat immediately after starting. This prevents spark plug fouling, ice formation, and improves fuel vaporization. Leave the cowl flaps open during warm-up. Closing them does not shorten warm-up time, but it may burn the insulation on the ignition harness. With ground check complete and engines warm, you're ready to go. If the plane has been parked, even for a short time, the skis may stick to the snow and prevent moving the plane even with full power. Here's how to break loose. Retract the skis to full up position. Increase power to normal takeoff limit. Then lower the skis to full down. As they touch the surface, they will move back relative to the wheels and move the aircraft forward. At this point, decrease power for normal taxiing. Takeoff, landing, and taxiing on ice runways is done on wheels. Ice runways have a gritty surface covered with about 4 inches of snow and pulverized ice. Operating on these runways is very similar to operating on concrete. Operating on snow runways is quite different. Here, skis are used. You can brake on snow by retracting skis so the wheels dig into the snow. Drifting or newly fallen snow makes a very slow skiway, and JATO may be needed for takeoff. When in position for takeoff, arm all JATO bottles and establish the firing cycle. Start a normal takeoff and continue until terminal velocity is reached. Then, if the plane isn't airborne, start the JATO firing cycle. After retracting wheels, place the skis in full up position. If left down, they cause drag, and they may be damaged by air resistance. When in a safe area, drop the JATO bottles. Now consider landings. Landing pattern, approach, and touchdown are normal. Fly the aircraft until it makes contact. Don't cut power until the aircraft is firmly established on its skis. You may even need power to maintain directional control during runout. Remember, skis can freeze fast if you stop, so keep the aircraft moving until you are well in the parking area. If the parking area is unprepared, taxi over it at least once and park in your own tracks. When parking on a hard snow surface, put the skis in down position to obtain maximum friction. On a soft surface, raise the skis so the wheels are embedded in the snow. Secure the aircraft to protect it from Antarctic weather. Cover the engines to keep out wind-blown snow. Cover the pitot tubes. Cover all vents. Make sure the aircraft can withstand hurricane winds. Drill holes for stakes if there are no dead men for tie-down lines. Pour water on the stakes to freeze them in place. Make fast all tie-down lines. In addition, put wind spoilers on the wings. Secure control surfaces with battens. Keep the parking area well policed. petroleum products cause rapid deterioration of snow and ice and should be cleaned up at once. You have just seen some of the techniques and procedures used in Antarctic air operations. The pre-flight check, takeoff, landing, and taxiing, and the protection of parked aircraft against the elements. These methods apply not only in the Antarctic. They can be used wherever planes are operated, in any comparable conditions of ice and snow, high winds, and extreme cold.